Okay guys, so here we will see what are the reasons for using Hadoop, what are the core component of a Hadoop. Guys, in this diagram you can see we have a MapReduce, we have an HDFS. These are basically a core component of your Hadoop. So I'll give you an example from where you can correlate the operation of this core component of Hadoop. Okay, let's suppose you have a file. Okay, let's take you want to execute an application. For executing any of an application, okay, for executing any of the work, you need two things. Basically you need two things. The very first is a line of code which will actually process your data, and the second thing is the raw data, input data, right? Of course, these are the two fundamental requirements. Now try to correlate that thing with my core component. So component is that HDFS is nothing, means it has data which you need to process. Now processing this data, you need a bunch of code, you need a line of code, and this is what is mentioned in MapReduce. So guys, map and reduce gives you a provision where user needs to write his own custom business logic. Optimize code, user has to write it over this part, and this part MapReduce is nothing, it's a processing unit, and HDFS has data. Okay, what is the concept behind HDFS, how data is stored, that we will discuss in our subsequent slides of the session. So from here you got an idea, okay, that Hadoop has two main components. First is a MapReduce, which will something act like a processing engine, and it has another component, second component, which is an HDFS. So it has data, it basically store the data. Fine. Now how data is stored, what is the optimization technique due to which it retrieve and fetch the data very fastly, that we will discuss it. So guys, Hadoop is an open source, so there is no need to purchase expensive license. Okay, we know that. It is scalable from one system to another system. Third one, due to fault tolerant failure of your system will not affect performance of the system. Guys, these 2 points somehow difficult for you to understand, but during our Hadoop architecture diagram, when we will discuss it, so would be easier for you to understand, because we have some diagrams is there. So from there you will get an actual idea what do you mean by these statements. So here just take a reference like that. Okay, system can be scalable, and second thing, irrespective of the failure of my system, it won't affect the performance of my system. Reason is that we have some kind of provision. Okay, so we will discuss these 2 points in detail in our when we will discuss the Hadoop architecture in this in our next slides. Fine. This point indicates this point which has mentioned is Hadoop is not bounded by a single schema. Types of data means Hadoop can be used to store either a structured data, unstructured data, or semi-structured data. So this is what exactly is mentioned here. Second last point is there is no need to pre-process the data before storing it. Means guys, we all know that the biggest advantage of using Hadoop over RDBMS is that RDBMS has certain limitation. Guys, when something is already exists in a market, why should I go to the second one, right? And RDBMS has certain limitation, restriction, in the sense that we cannot use it for the unstructured data, but Hadoop can be used for unstructured data, right? So I mean, something will hit in your mind that okay, means you can store unstructured data, means you will process it, you will do some kind of pre-processing. But guys, the best part is that if you will process that data before storing it, means the possibility and probability of losing the data will always remain there, will always be high, right? But Hadoop has the has that feature provides you the provision that it will store the data as it is, right? Due to which the data will remain in its richest form, so that you won't lose any bit of the information. So this is the main advantage of using Hadoop, and this what exactly is mentioned here. And the last point is the Hadoop can be deployed on commodity hardware. Guys, commodity means cheap, which is not expensive. So let's suppose you can consider, I'll just give you one more idea. let's suppose we have one master, few masters. Okay, let's suppose we have few masters, and we have some nth slaves. So this is the fashion how Hadoop works in a master slave concepts. So this block we, okay, actually this marker is not working. Let me clear it once again. I'll take a pen. Okay, I'll take a highlighter. Guys, this is master and this is slave, let's suppose. Fine. Oh, this is master. M stand for master, this stand for slave. Fine. So guys, so the fact is we have a few masters and we have a few nth slaves, right? So it works in this fashion that we have a master, we have a slave. From the master we will do some kind of operation, on slave we will do some kind of operation. So just by adding few nodes on the slave side, right? Now just by adding few nodes of this at the slave side, the processing speed of a Hadoop system will be increased a lot. But the best part is that all the slaves, whatever you will deploy for your Hadoop cluster, is generally deployed on your commodity. So due to which the overall cost of your slave system would be cheap. So this is the meaning of your last statement. So all the nodes which are deployed for slave, it generally run on commodity hardware. So due to which the overall cost of your system would be cheap. Fine. Okay, so let's move on the next slide.